Today, we are going to talk about exponential models. So what is our lesson objective? At the end of the lesson, you must be able to represent real-life situations using exponential functions. So what is graph of exponential functions? It is defined by f of x is equal to b raised to x, where b is greater than 0 and b is not equal to 1. It is an increasing function if b is greater than 1. It is a decreasing function if 0 is less than b, less than 1. Now, what is a growth factor? It is formed by adding the specified percent increase to 100% and then changing to its decimal form. So, let's take some examples. We will determine the growth factor of the quantity that increases by the given percent: 50%, 75%, 10%, and 12.5%. So for 50%, 100% plus 50% is equal to 150%. So in decimal form, that is 1.50. For 75%, 100% plus 75% is equal to 175%. In decimal form, that is 1.75. For 10%, that is 100% plus 10% is equal to 110%. In decimal form, that is 1.10. And for 12.5%, 100% plus 12.5% is equal to 112.5%. So in decimal form, that is 1.125. So let's take another example. Ryan Roy deposits 50,000 pesos in a savings account. The account pays 6% annual interest. If he makes no more deposits and no withdrawals, calculate his new balance after 10 years. The interest represents a 6% rate of growth per year. So the growth factor, or the constant multiplied, is 100% plus 6% is equal to 106%, or 1.6. To find an equation that can be used to find the new balance after any number of years by considering the yearly calculations, we have this equation. So we can use now this equation. The y is equal to 50,000 multiplied to 1.6 raised to x, where x represents time in years and y represents the new balance in pesos. To find the new balance after 10 years, we have y is equal to 50,000 multiplied by 1.6 raised to 10 is equal to 89,542.38. So the new balance after 10 years is 89,542.38 pesos. Now, what is the exponential growth? The rule for exponential growth can be modeled by y is equal to a and b raised to x, where a is the starting number, b is the growth factor, and x is the number of intervals. It can be minutes, years, and so on. Let's give another example. A bacteria grows at a rate of 25% each day. There are 500 bacteria today. How many will there be tomorrow, 1 week from now, or 1 month from now? So let's answer, how many will there be tomorrow? So using the formula y is equal to a and b raised to x, where a is equal to 500, b is equal to 1.25, and x is equal to 1, then y is equal to 500 multiplied by 1.25 raised to 1. We are going to substitute 500 for a, 1.25 for b, and 1 for x. So the answer is 625. There will be 625 bacteria tomorrow. How about 1 week from now? Again, using the formula y is equal to a and b raised to x, where a is equal to 500, b is equal to 1.25, and x. So remember, there are 7 days in 1 week. Then y is equal to 500 multiplied by 1.25 raised to 7. The answer is 2384.19. So there will be 2384 bacteria 1 week from now. So how about 1 month from now? Again, using the formula y is equal to a and b raised to x, where a is equal to 500, b is equal to 1.25, and x, so there are 30 days in 1 month. Then y is equal to 500 multiplied by 1.25 raised to 30. So we are going to substitute 500 for a, 1.25 for b, and 30 for x. So the answer is 403,896.78. So there will be 403,897 bacteria 1 month from now. Let's talk about exponential growth models. So if a certain quantity increases by a fixed percent each year, the amount y of that quantity after t years can be modeled by the equation y is equal to a multiplied by 1 plus r raised to t, where a is equal to the initial amount, 1 plus r is equal to growth factor, r is the percent increased expressed as decimal. A real-life application of exponential growth occurs in the computation of compound interest. So the formula for the compound interest is a is equal to p multiplied by 1 plus r over n quantity raised to n multiplied by t, where a is equal to compound amount, p to principal, r is equal to interest rate, t is equal to time in years, and n for period per year. For example, James Ryan invested 50,000 pesos at an annual rate of 6% compound yearly. Find the total amount in the account after 10 years if no withdrawals and no additional deposits are made. So we are going to use the compound interest formula with P is equal to 50,000, R is equal to 0.6, N is equal to 1, and T is equal to 10. So 50,000, we are going to multiply by 1 plus 0.6 over 1 and quantity raised to 1 multiplied by 10. So that would be 50,000 multiplied by 1.6 raised to 10. So our answer is 89,542.38. So there would be 89,542.38 in the account at the end of 10 years. So that's all for today in exponential models. I hope you learned something and thank you for watching.